Hello everyone, and welcome to our special interview on quantum-safe offline central bank digital currencies. Today, we're diving into the fascinating world of quantum computing and the future of digital currencies. Joining me are two esteemed guests, Jerome and Emmanuel. Jerome is our VP of Digital Currencies, and Emmanuel is a distinguished expert in cryptography. Together, they will shed light on the looming quantum threat, its impact on CBDCs, and the innovative solutions IDEMIA is developing to ensure secure digital transactions in a quantum-enabled future. Let's get started. So, Emmanuel, what is the quantum threat and how does it pose a risk to CBDCs?
Well, quantum computers rely on quantum mechanics to represent data and perform operations. And as such, they provide a computing model which is completely different from the one of our classic computers. Given this new computing model, researchers are inventing ways to use it to perform some operation much faster than with classical computers. Several domains are involved. For instance, it could be used to design new molecules in chemistry. Cryptography is also impacted, but this time in a rather negative way. To understand how, let's recall that the security of most cryptographic algorithms rely on some mathematical problems. For instance, the widely used RSA algorithms is secure because we cannot factor big numbers efficiently. The fact is that with a quantum computer, we know it will be easy. So easy that we cannot repair RSA by, saying, enlarging keys. And this is true not only for RSA, but for the whole family of public key cryptography that we use today. And this means that as soon as a powerful enough quantum computer is available, traditional cryptography will fail to ensure the security of our data.
And when will this happen?
That's a great question. While it's true that quantum computers are today too small to be practical, quantum computing is a very active field with significant investments for major companies. A 2023 study suggests that most experts believe breaking RSA keys could be possible within the next 15 years. One thing is for sure, we don't want to be caught unprepared. This is why the cryptographic community has been tackling this issue for almost a decade now. And the NIST will release this year the specification for new post-quantum algorithms. This algorithm will run on traditional chips, but they rely on different mathematical problems which are tough even for quantum computers. We will use these algorithms instead of the classical ones to ensure our products are secure even if quantum computers become powerful.
So, Jerome, why is this important regarding CBDCs?
You know, Christina, it's all about timing. Quantum computers are coming in the coming years, and CBDCs are being developed now by central banks and will launch before the end of the decade. So the two phenomena arrive at the same time. So this is why we need to get prepared. Quantum computers will render existing cryptography obsolete. This means that in a CBDC solution, like any digital payment solution, it relies on cryptography. It means that CBDC could be broken. An attacker would be able to double spend currency or even to mint, to create unauthorized currency. This is an unacceptable threat to the central banks. And this is why we need to get prepared now at the design phase.
So, Jerome, what are you announcing today?
So today we announce, in fact we are very proud to announce, the first ever quantum safe offline CBDC transaction. So what did we do? Our R&D team managed to integrate a quantum resistant, a quantum safe cryptographic algorithm in a secure element, in that case, in a SIM card. So today we have a functioning solution for quantum safe offline CBDC.
Can you show me how it works?
Sure, let's do that. So this is your phone. It's loaded with your bank simulated, of course, your bank's payment application, and you will be receiving payment. I will send you 10 euros. So just go on your app and you will request 10 euros. So I will send you 10 euros. Tell me when you're ready.
Ready.
Okay, so now I send you 10 euros and it works. Did you receive it?
Yes, I did.
Here, we used, of course, a secure element in order to secure the transaction. In that case, a SIM card in your phone, a SIM card in my phone, and both SIM cards embed the latest NIST algorithm that are quantum safe.
So Emmanuel, how was this made possible?
Well, this demonstrator is part of a long history of research, development and innovation at IDEMIA. Back in 2019, we showcased the post-quantum signature algorithm on a smart card. Then in 2021, we presented the first quantum-safe 5G SIM card. The next year, in 2022, a post-quantum version of an EMV payment card. And now in 2024, we're just demonstrating the first post-quantum solution for offline CBDC payments. In this use case, traditional cryptographic signatures are used to ensure the integrity and the trustworthiness of the financial transactions. And as Jérôme explained, we have replaced them with post-quantum version to ensure we have a product which will be secure even when quantum computers are available.
So what's next for IDEMIA in quantum-safe CBDC?
Well, first, we will need to fine-tune the post-quantum mechanism. This initial experiment will help us determine which post-quantum algorithm and parameter fits the best this CBDC use case. At the same time, in-house chip design team is working on new chips specifically tailored for these post-quantum algorithms. They will have more RAM and secure hardware accelerators adapted for the new mathematical operations. While our result is already effective, these new chips will help us achieve even better performances. And finally, we need to implement two features that are crucial for the long-term security of the product. It's the hybrid approach and the crypto agility.
And can you tell me what a hybrid approach and crypto agility are?
Yes, well, first, the motivation for them is that the post-quantum algorithms are still young, meaning that in the coming year, it is possible that we found some attacks. So we need to take precautions. The first one is to use so-called hybrid protocols. Hybrid protocols use at the same time classical cryptography and post-quantum cryptography. The idea is that they are secure unless both the classical crypto and the quantum crypto is broken. And this allows us to prevent any regression during the migration. The second one is the crypto agility, which is the ability to modify or even add a new post-quantum algorithm on a chip without needing a recall. Crypto agility is especially challenging for embedded products like smart cards, where resources are constraints. And IDEMIA demonstrated the first crypto agility solution on a smart card product just a few weeks ago.
And Jérôme, how are you going to integrate post-quantum in your secure offline CBDC offer?
So today, we have a prototype that is running. Next step, as you mentioned, is to integrate it in our roadmap, to integrate it in our secure offline CBDC offer, to port it to other form factors. Smartphone is great, but also smart cards, for example. But most importantly, we will need to continue working with central bankers. And this message is really to you, central bankers. We already collaborate together, but we need your feedback. We need your insights on the best way, on your expectations as it regards the future-proof solutions we are developing today.
Thank you, Jérôme and Emmanuel, for sharing your insights. To our viewers, thank you for joining us today. Stay tuned for more updates and follow us on social media to learn more about our groundbreaking work on quantum-safe solutions.